Hello friends, welcome back to CSharp.net online training video series. Today we are going to discuss one of the most important concept, that is delegates. In our previous video, we have already discussed what is the role and responsibility of events, delegates, events handler. Today we are going to keep focus on delegates. So what is delegates? In simple word, we can say that a delegate is a types of function pointer. What do you mean by types of function pointer? It means the delegate hold the reference of a function or a method, and when we invoke the delegate, the method or the function which is referred by the delegate, that method is going to be executed. If this is not clear at the moment, then don't worry, we will discuss this with some real-time examples, right? So once you start discussing the examples or once you start discussing the programs, then you will understand this point, right? Then the next question that comes to your mind is how to create delegates in C Sharp. See, in C Sharp, it's very simple process. It's very simple process to create the delegate. So what we need to do is we just need to use the delegate keyword. And when we use the delegate keyword, then the delegate is going to be created. And you can see it's a magic keyword, because when you use the delegate keyword and when compiler sees the delegate keyword, then compiler what it does behind the scene. Compiler actually generate a class for your delegate, and that class is inherit from some of the .NET framework classes called the multicast delegate, right? If how it is going to create the class, how the base class is going to be multi-class delegate as part of the class, what are the things available, right? All these things we are going to discuss in detail in today's video, right? So the syntax to create a delegate in C# is very much similar the syntax of abstract method declaration. What do we know in abstract method declaration? Now we just need to use the abstract keyword without method body, right? And we need to end the method with a semicolon. The same process is also here. Instead of abstract keyword, what we need to use here, we need to use the delegate keyword. See, this is access specifier that might be your public, private, protected. You have to use the delegate keyword, right? Once you use the delegate keyword, then you need to provide the return type. If your method, right, if your handler method is going to return something, then you need to provide the specific return type. If your handler method doesn't return anything, then you just need to use the void. Then you need to provide the delegate name, and then you need to provide the parameter list, right? And the following is an example, right? So you can see here I'm creating public and the delegate keyword, and the return type here I'm saying void, and I'm providing the name of the delegate as work perform handler. And here this method taking two parameters here, integer hours and work type work type. What is this work type? It is basic, it is going to be an enum in our example, right? So as this method, as this delegate return type is void, means the method or the delegate is never going to return anything, right? It is only going in the forward direction. And the name of the delegate is work perform handler, and it is taking two parameters, right? So what is delegate in reality? In reality, a delegate is a blueprint for the method. What it means? It means, see, why I'm saying it is a blueprint for the method means, see, we have already discussed the concept of class and object. Class is what? Class is just a blueprint, right? Once you create the object of the class, then they will come into the picture, right? They will get memory. So whatever data member variable you created, they will come into the picture when you only create the instance of the class. Similarly, this is just a blueprint for a method, right? Blueprint for a method means they are actually going to hold the method references, right? And when you create an instance and when you invoke the delegate instance, right, then the method that what the delegate pointing to is going to be executed. And what is the use of a delegate means? It is going to dump the data into the event handler, right? In our previous video we have discussed, there is a in our previous video we have discussed, okay, let me open that diagram so that you will get better clarity, right? So in this case you can say this is my event raiser and this is my event handler, and the event raiser raised the event, right? And this is the event handler which is going to handle the event data, right? The event raiser sends some event data, but how the data is going to be passed? Through this pipeline, right? This pipeline is nothing but your gate. delegate, right? So delegate is nothing but it is the component which is making the link between your event raiser and event handler, right? And from the delegate only your event handler is going to get the data. Or in other word, you can say whatever the event handler method registered with the delegate for this particular event, this delegate is going to dump the data into those methods, right? So in simple word, we can say delegate is basically going to dump the data into the event handler method, right? Now let's say we have some data in our program, right? And we want to route the data over to the handler method. How we can route the data into the handler method? Suppose your data is here, your handler method is there. How you will pass this data to the handler method means you have to use the pipeline. And the pipeline it is nothing but your delegate, right? So you will provide the data to the pipeline and the handler method will get or take the data from the pipeline, right? So using this pipeline only or using this delegate only, we can route the data from one point to another point, or you can say we can route the data from the event raiser to the event handler, right? And in this case, you can see if you look at this delegate signature, this is nothing but the pipeline. As this pipeline contains two parameter, integer hours and integer work type. So whenever you are going to send the data, you can only send those piece of data, those two pieces of data. You cannot send other data, right? And this handler method, if he wants to get the data from this pipeline, again, this handler method should have these two pieces of data type, right? If this handler method doesn't have integer and work type data type, then he cannot get the data from this handler method, right? So now let us try to understand what the handler method must do in order to work with the delegate, right? First of all, this is the delegate signature. This delegate contains two parameter. One is into work type and one is integer and another is work type. That means if the handler method wants to get the data from this pipeline, then the handler method must and should have the same data type as the delegate data type. So the delegate signature and the handler method signature must be matched. This is the point that you need to remember. Why it should be matched? Because the handler method going to get the data from the pipeline, right? If the pipeline having some data, that means the same data this handler method going to get. Right? If data type is suppose here integer and you declare one boolean data type, then how you can store and how you can get the integer data and how you can store the integer data in a boolean data type? It is not going to be possible. That means the handler method signature and the delegate signature must be matched, right? As we define the delegate with two parameter, right? Or you can say as the delegate taking two parameter, the handler method must and should be taking two parameter, right? If this handler method not taking two parameter means he cannot get the data from the pipeline. That is what you need to remember. See, this is your delegate declaration. You declare the delegate. You can see it using the delegate keyword, and this is nothing but your uh, delegate name, and this delegate taking two parameter. And this is my handler method. And if you compare these two things, then this is nothing but a blueprint of this method, right? So you can see this method return type is void, same as the return type of a delegate. This delegate access specifier is public, and here the access specifier is public. Again, you can see this delegate taking two parameters. First one is integer, second one is work type, and this handler method is also taking two parameter. One is integer and the other one is work type. And coming to the name you can give anything, right? Here you can see in the delegate I'm giving hours and work type, and here I'm giving work hours and a W type. So name you can give anything, but the signature is must be same. So the point that you need to remember is while working with delegate, the signature of the delegate and the method it points to must be same. So when you create a delegate, then the access specifier, right? Access modifier, return type, the number type and order of a parameter of the delegate must and should be same as the access specifier, return type, number type and order of a parameter of the function that the delegate wants to refer, right? You can define the delegate either within a class or just like other types we define inside here. We'll come to this point once we start programming. Right now, what happens behind the scene when our delegates, uh, when we create our delegates, right? So now we are going to discuss what happens behind the scene with our delegate. That is, we are going to discuss the delegate base classes in .NET Framework, right? So one of the core built-in abstract class in .NET Framework is Delegate that provides some base functionalities, right? If you go to the definition of the Delegate class, then you will see that it is an abstract class as shown in the below image. Okay, let me go to the Delegate. So let me type Delegate. Yeah, this is my Delegate class. And once you type and once you right click and go to select go to definition, it will take you to the definition of the class. So you can see this is the delegate class. So represent a delegate, which is a data structure that refer to a static method or to a class instance and an instance method of that class, right? So that means it is a delegate and it is an abstract class, and that delegate providing some important properties and method. So here you can see two important properties, method and target, right? And here you can see another important properties, get invocation list. These are three important property, the members we are going to discuss. What is this method property? What is this target property? And what is this get invocation list that we are going to discuss, right? So what is this method property? This property is used to get the method represented by the delegate, right? Right. What it means, suppose you created this delegate instance. And while you are creating the delegate instance, you register this method. That means this delegate now pointing to this method, then that method property is going to return the signature of this method. What is the method signature? On this delegate pointing to, that is going to be written by the method property, right? And what this target property is going to return means, if that method, if this method is a non-static method, then what is the class name? What is the namespace name this method belongs to? That fully qualified class name is going to be written by this target property, right? But if this method is a static method, then this target property is going to return no, right? Right. The pipeline has to dump the data somewhere, and the method property defines the name of the method where the data is going to be dumped, right? So see, at runtime, what is going to happen? At runtime, this pipeline is going to dump the data some in some handler method. Then how it will decide on which method I need to dump the data based on that method property, right? The method property returning you the method signature, then based on that method signature, this pipeline is going to dump the data into that method only, right? So the second point, what is saying, the target would be the object instance where the method lies, right? That means if the method is a non-static method, right, then from which class and from which namespace that method belongs to, that fully qualified name it is going to give. And in the case of static, it is going to return you null. If the delegate invokes one or more instance method, the target property returns the target of the last instance method in the invocation list, right? It is also possible that one delegate might be pointing to multiple methods, right? In that case, what is the last method pointed by the delegate? That method details is going to be returned by the target property. And in the delegate abstract class, we are having one important property, not property, it is actually a method that is get invocation list, and this method will return you an array of a delegate. Suppose you create one delegate and that delegate is a multicast delegate. What is multicast? What is single cast? We will come to we'll discuss further, right? Suppose you created one delegate and that delegate pointed referring to multiple functions, right? Suppose that delegate referring to three functions, then this delegate get invocation list property will return a delegate array of three elements, where the first delegate will point to the first function which is referred by the delegate. Second element, the second delegate is pointing to the second function, and so on, right? So once we discuss multicast delegate, then we'll discuss this invocation list method in detail, right? So another class that is available and that is related to delegate is multicast delegate, right? If you go and if you check, this is delegate, and if you check multicast delegate, then it is also a class. And if you go to the definition, then you will see that this class is inherited from the delegate class. That means it is also a base class, but this it is also an abstract class, and this abstract class is also inherited from another abstract class, or you can say base abstract class, that is delegate. So this is also one abstract class. And guys, remember me, and whenever we create a custom delegate, right, whenever we create a delegate behind the scene, the compiler when sees the delegate keyword, it is going to create a class, and that class is going to be inherited from this multicast delegate. As that class, as it is inherited from the multicast delegate, so the custom delegate what we are going to create, they can refer to multiple functions, right? And one more thing that you need to remember is, right, we cannot directly inherit our custom class from multicast delegate or a delegate. This is the restriction provided by the .NET framework, right? What you need to do is you need to create the delegate by using the delegate keyword, and behind the scene, the compiler will do all the rest of the things, right? The compiler will generate a class for your delegate. The compiler will inherit from this multicast delegate. The compiler will provide the necessary methods and constructor as part of your delegate. That we will discuss. I will show you all these things practically by using the ILDSM, right? So what you just need to remember is you have the base abstract delegate class. From that class, you have a multicast delegate, and from multicast delegate, you are creating the custom delegate. That means whatever the method properties available in delegate that are inherited to multicast delegate, and from multicast delegate, those are inherited to our custom delegate. Okay, so one important point. The point that you need to remember is in your code while declaring the delegate, you cannot directly inherit from the delegate or multicast delegate. If you are creating a class or if you are creating a delegate, you cannot inherit that delegate from either delegate or multicast delegate, right? What you need to do is you just need to use the delegate keyword, right? You just need to use the delegate keyword, and rest of the things are going to be done by the compiler, right? These are special base classes which compiler restrict us to directly inherit. Once the compiler sees the delegate keyword in the signature, then it will automatically generate the class that inherits from the multicast delegate. Okay, let us see this. Okay, let me first create a delegate. Let me first declare one delegate. Let me increase the size of the font. So you can see this is my delegate. Right, this is my delegate. You can declare the delegate within a namespace like a type, or you can also declare the delegate within a class. That is also possible. So both approaches are possible, but what I generally prefer to declare within a type, because it is going to be a class. So as it is a class, so I'm going to declare like this. So this is how I'm going to create the delegate. So this is the declaration of a delegate. So what you need to use the syntax like access specifier, delegate keyword, return type, delegate name, number of parameters, end with a semicolon. So this is my delegate. So you can see this is the signature. Now what I'm going to do, I'm going to create one handler method for this delegate. That means if I'm going to use one handler method, then the method signature should and must be same as the delegate signature. So you can see this is the public method, and here I'm writing this as a public method, right? And the return type is void. Here the return type is void. This is work perform handler method delegate name, and I'm giving a different name to my handler method. And this method delegate taking two parameters, I'm also taking two parameters. And remember what is work type? Here it is nothing but an enum, right? This is nothing but an enum, right? Now what I'm going to do is let me compile this application and let me show you the IL intermediate language code, and let's prove that this delegate behind the scene, it is going to be a class. Okay, let me go to the location where the exe is generated, win debug, and this is the path of my exe, right? Let me open Visual Studio Developer command prompt, right? Okay, yeah, I'm opening Visual Studio Developer command prompt. Let me type ILDASM, and once you type, it will open the uh, intermediate language disassembler tool, right? So go to the location where your exe is generated, select the exe and open this one. And once you open this one, you can see delegate real-time example. This is nothing but your namespace, and inside this namespace we have three types. So you can see the last one, it is saying e means it's a enum, but this is you can see blue color, these two are nothing but your class. One class name is program, another class name is work perform handler. Do you have declared any class with the name program? Yes. Do you have declared any name work type as enum? Yes. But if you look at this work type and work program is there, but what is this work perform handler? It is a class, but we have any class? No, we have declared any one delegate. But remember, when the compiler sees this keyword delegate, then it will convert this delegate into a class, and that is the class you can see here. And if you further expand this, then you will see that this class is nothing but it's going to be a shield class. You can see shield class, and this class is inherited from the multicast delegate. So you can see this is multicast delegate. So what we have discussed at our first abstract delegate class is that from abstract delegate, multicast delegate class is inherited. From multicast delegate, this is the class what we have created is inherited. And you can see this is the constructor, right? This constructor, you can say object and native int, right? And here you can see begin invoke, end invoke, and invoke. These are the method that we can invoke on the instance of this delegate, right? We'll see this how to use these methods, right? So that is what you need to understand. So behind the scene, when you create a delegate, behind the scene, when the compiler sees the delegate keyword, it is going to create a shield class, and that class is going to be inherited from the multicast delegate, and that compiler is going to provide some of the method, right? Implementation of this method, and using that instance, you can invoke this method, right? I will show you how to create an instance of delegate and how to invoke this method and how to use this constructor that I'm going to show you in some time, right? Now, how to use delegate? How to use delegate means how we are going to use the delegate to route the data. So why we are using delegate? Delegate means we are going to route some data from one location to another location. For this, we need to create an instance of the delegate. And while we are creating the instance, we need to pass the method name or the handler method name where we want to dump the data. If the handler method is a static method, right? If the handler method is a static method, then we need to specify the method using the class name or directly if both are present in the same class. And if it is a non-static method, then you need to use the object instance, right? We'll show you, I will show you both approaches. But now see, this is the step one, declaration of delegate. This is step two, creating the handler method name whose signature is same as the delegate, right? And this is the creation of a instance of delegate, right? You can see we just need to use this delegate like a class only. So class name, reference variable name, new constructor. So this is nothing but your constructor, and to this constructor we need to pass the method name as a parameter. You can see this manager that work from, it is a static method, so I'm passing that method name directly as a parameter. As this delegate referring to a function, right? And when we create an instance of this delegate and when we invoke this delegate instance, the function that is pointed by this delegate is going to be work, and this is the reason why we are saying delegates are nothing but function pointer, right? So this is the process of declaring delegate, creating handler method, and creating an instance of the delegate, right? Then how to invoke the delegate? Invoking a delegate is also very simple. What we need to do is we need to call the delegate instance like a function, and while calling the delegate instance, we need to pass the parameter, right? The way we pass parameter while calling a function, in the same way we need to pass the parameter while calling the delegate instance. In this case, what is the name of the delegate instance? Del1. So you can write del1, and this delegate while calling you need to pass to parameter, right? So if you remember this delegate, right, having to parameter or not, integer hours and work type. So while invoking the delegate, you also need to pass to parameter, right? And for better understanding, please have a look at this image. So this is your delegate declaration, right? This is your handler method. This is creating instance of a delegate, and this is delegate calling, right? So when I invoke this delegate, so I'm passing 10 and the work type dot call pass parameter. So this delegate is registered, right? This delegate one, this handler method manager underscore work perform. This is the handler method which is registered with this delegate. And when we invoke this delegate, right, the delegate will check the method property, right? What we have already discussed. And from that method property, it will get this signature. That is the return type void, this method name, this parameter, all these things, and then it will invoke that method. And while invoking that method, what you are passing as the first parameter, that will be passed to the first parameter of the method. What you are passing as the second parameter, that will be passed to the second parameter of the method. And once we pass the parameter and invoke the method, this method invocation is going to be executed. This method is going to perform the rest of the task, right? So let us understand the whole things into one example, right? So let me copy the code. Let me put it here. See, first step, create one delegate, right? So creating delegate. Second step, create the handler method. I'm creating the handler method. Whatever business logic you want, you can write here. And this is my enum type, which is containing three properties. So you can say these three are nothing but enums are nothing but named constant, right? Once we progress, right, in our upcoming session, we'll discuss what is enum. But for now, you just remember these are nothing but named constants, right? And this delegate taking one integer parameter and one enum type and one enum type of work type. And while creating the delegate instance, I'm passing this method as a parameter, right? So you can see as this is a static method, I'm passing this, right? And even if you want, you can also pass this parameter by using the class type. That is also fine. That is no issue. Then there are two ways to invoke the delegate. You can invoke this method like this, right? Del. And if you remember in the ILDSM tool, right? In the ILDSM tool, I have shown you that there is a method, right? I have shown you that there is a method called invoke is available inside your delegates, right? So you can see this is a invoke. So you can also use that invoke method to invoke the delegate instance. And I am invoking, while invoking, I'm passing first parameter as the integer parameter and second parameter is the enum type values, right? And when we invoke this delegate, then this delegate del1 is pointing to this method. That means this method signature or this method definition is going to be executed, right? Now let us run the application and see the output. So once you run this application, then you will see that the handler method is going to be executed two times because from our main method, okay, it is not going to run. Why? Because we have opened this ILDSM tool. Let me close this one right now. Now, once you run this application, then you will see that the handler method is going to be executed two times. Why two times? Because we have executed, we have invoked that delegate instance two times. One is this one and another one is this one, right? So both of the approach exist. So whichever approach you like, you need to use that one, right? I generally use the other approach, that is the invoke method, because it explicitly telling me that we are invoking this delegate. Now, if this method is a non-static method, then what will happen? Now, if this method is a non-static method, then you need to create an instance of the class program p equals to new program, and using that instance only, you need to call them right like this. Now, if you run the application again, you will see the output as expected. That is fine, right? You can see the output. Okay. How to invoke a method using delegate means it's a two-step process. First, you need to declare a delegate. So this is your step one, declare a delegate. Then you need to instantiate a delegate. So this is nothing but your instantiation of a delegate. And then you need to invoke the delegate. And this step is nothing but your delegate invocation. This is the three steps that you need to understand. But now if I'm asking you, does it require to create one delegate? Does it require to create an instance of the delegate? Do I need to invoke this delegate like this? Why I'm going to do all these things? I can simply create an object and I can simply invoke this method like this, right? Yes or no? So I can simply create an instance and I can simply invoke this method like this, right? So if I can invoke this method like this, then why I'm going to create the delegate or perform? Why I'm getting go to meeting? Okay, go to meetings. Okay. So why I'm going to do all those data things? Why I'm going to create a delegate in delegate instances or delegate invocation? I can simply call this method. Is there any requirement? For this particular example, there is no need to create a delegate. Then where I'm then in real time where we are going to use the delegate, right? Suppose someone asking in the interview what is delegate, Yes, delegate is a function pointer. When we are creating a delegate instance, we need to refer the method, and when we invoke the delegate, that method is going to be executed. That is fine. But for just invoking a method, we are not going to use delegate. The delegate reason is they are going to be used as a callback method, right? If you want to execute any callback functions, then in that scenario, you need to use delegate. So delegates are used to invoke the callback functions. What it means? We will invoke one function and we will pass the delegate instance as a parameter to that function, and we expect that function to invoke the delegate at some point of time, which will call the which will call back method, and that referred by the delegate, right? If this is not clear at the moment, let me explain you this with one example, right? So what I'm trying to do is, see, here you can see, here I'm having one method to do some work, and here I'm having one callback method. Okay, so this do some work method, he have no idea related to this method. What is the method name? He have no idea. In this case, I'm creating these two method in the same class. That's why you can see and look at this method, but think that this method is available at a different location, different class file, right? And that method, that method details this do some method have no idea. But what is my requirement is, when I invoke this do some work method, I need to provide, I want another method to be invoked by the do some work method. But directly you cannot pass a method as a parameter. So in this case, you cannot pass this do some work method as a parameter. This is not possible because this is not a type. But this callback method handler, in this case, it is nothing but a delegate, and we have already discussed that delegate, it is nothing but a class, and a class is a user defined data type. That means you can pass a delegate as a parameter. So what is my requirement is, from this main method, I will invoke this method do some work, and I will ask this do some work method to invoke a method which I am going to pass at runtime. At runtime, it might be this callback method, or it might be a different method. That method details will not be provided to this do some work method. Do some work method, I have no idea what method I'm going to invoke at runtime. But what this do some work method is going to do, it is going to invoke this delegate, and this delegate instance, right? So this is nothing but a delegate. Delegate means, that means while creating the instance, that instance must be pointing to some other method. That method is going to be executed at line number 23, right? So this is nothing but your callback method. So we are calling one method, and we expect that method to call me back or call some different method. So in this case, you can see I'm creating the program class instance as right? And while I'm creating the delegate instance, I'm passing that callback method. So that means in this method, main method, I'm not going to invoke this delegate, right? I will pass this delegate as a instance, this delegate instance as a parameter to this do some work method, and that do some work method is going to invoke the delegate. And when this do some work invoke this delegate, then this delegate, what method is pointed, what method it is pointing, that method is going to be executed runtime, right? So without delegate, it is not possible to pass any method as a parameter to this function, right? So you cannot pass method as a parameter. Yes, you can pass method as a parameter only via this delegate, right? Now if you run the application, then you will see that this method is going to be executed first, and when this delegate is invoked, that delegate will actually invoke this callback method, right? So let me run the application and show you the output. So yeah, you can see processing some task. Processing some task means do some work method started, and then it will calling the callback method, and you can see callback method executed, and the message what you have written, that is going to be displayed. This is nothing but how you use do some work, how you use delegate to invoke callback method. Now in the beginning, I have shown you three important properties. What are these method? One of the property is method, another property is target, and another property is invocation list. Let us try to understand what is the use of those properties. So in this case, you can see I'm having one handler method, right? To some method handler, and this handler method having one parameter, and it is returning void. And to this right, to this, what I'm trying to do, I'm creating a different class called sum class, and inside this sum class, I'm having one do some work method, and if you compare the delegate signature and this do some work method signature, both are going to be same. That means it is a void returning method, right? And its return type is void, and it is a taking string parameter, and this method is also taking string parameter, and this access specifier is public, and the access specifier of this method is also going to be public. That means the method signature is going to be same. Now what I'm trying to do, uh, I'm creating an instance of this do some method handler, and in this case, this do some work method is created as a non-static method. So I'm creating one object of that class, some class, and I'm just writing obj dot do some work method, right? And this is the instantiation of our delegate, right? Once the delegate instantiation is completed, I'm calling the method property. So this method property will return me the method signature, this delegate pointing to. This delegate pointing to which method? Do some work method. What is the signature of that method? That is going to be written by this method property, and you can store that inside the method info class, right? And you can see that method info, it is going to print, it is going to display the details of that method. Del one the target. Target means first of all, it will check what method this delegate handler pointing to. This delegate handler pointing to this method. Is this a static method or non-static method? It is a non-static method. If it is a non-static method, then it will display the class name and the interface name from which this method belongs to. This method belongs to which class? Some class. This some class belongs to which namespace? Delegates demo. So this target property is going to display you delegates demo dot class name is some class, right? And this invocation list means it is going to display you the handler details. So currently this delegate one having only one handler method, this one. So it is going to return you one array of delegate, and in that delegate you will see that only one handler, right? And if you are creating multiple handler, then it is going to return you multiple handler. Okay, let me do the same thing. Okay. So let me create another method, do some work too, right? Okay, let me first run this one, then I will show you the other. Okay, so in this case, you can see I'm looping through this array and I'm just printing the name. What is the handler method? What is the handler name? That is I'm going to display. Okay, now run the application. So once you run the application, then you will see the details as expected. See, so method name. Method name means what is the signature of a do some work method. So the signature of do some work method is void do some work, and it is taking a string parameter. That is target property means from this method belongs to which class and which namespace. It belongs to delegates demo dot some class. Delegates demo is the namespace, some class is the class name. And currently invocation list, it is having only one delegate. So you can see that loop while I'm running through this loop, it is only showing me delegates demo dot to do some method handler, because this is the handler method name, and this handler belongs to this namespace right now. Now I'm going to do some changes. What changes? Now instead of this void do some work, I'm making this as a static method. So once I make this as a static method, then I need to invoke that method by using the class, some class. So once I make this as a static method, then you will see that this target property is going to return me no, because it's a static. So for this static method, object instance is not required. If object instance is not required, then in that case, this target property is going to return me null. So let me run the application. Null means you cannot see anything blank, but it's actually a null value, right? Now what I'm trying to do, I'm creating two methods. Let me, this is to some one and this is to some two, and making this as a non-static method, right? And to some method of one. And what I'm trying to do is both. So see what I'm going to do right now. Don't confuse, right? We'll discuss this thing again in our next video, right? Next video in the sense when we discuss multicast delegate, right? So in this case, what I'm trying to do is I'm creating one delegate instance, but with this instance, I'm handling two methods, right? Two methods I'm registering with this delegate instance, right? So in this case, this invocation list, it is going to return me an array of two delegates. One delegate pointing to do some work method and another delegate pointing to the do some work to method, but both the delegate are going to be same. Same in the sense the same class name it is going to return, right? Let me run this application. You can see from method name void do some work to, and target property is this one, and invocation list you can see why it is returning method name property do some work to. Why not to do some work? Because in the invocation list, right, in the invocation list, first one is registered this method, the second method that is registered is do some work to. So this method property and target property always going to return the last latest method that registered within the delegate. So in this case, latest method is do some work to. So this do some work to method details going to be written by this method and the target property, right? So this is what you need to understand. What is the rule? A delegate in C# is a user-defined type, and hence before invoking a method using a delegate, we must have to define that delegate first. So you can see I'm defining this delegate first. The signature of the delegate must match the signature of the method the delegate points to, otherwise we will get compilation error. You can see this is the delegate. This delegate taking void, return type is void and taking one string parameter. And you can see I'm creating two methods. Two method, one is static method, non-static method, no matter. But what matter? Void. Void is there, void is there, message property and message group taking one string parameter. Now if I see, let me change the signature. Okay, let me add another parameter. So currently this do some work method taking two parameters, but as this method signature is same as this delegate no, then you can see while registering that method you will get a compilation error. This is the reason why delegates are said to be as a function pointer, because it is going to strictly check the signature of the method that you are trying to register with the delegate and the delegate method signature. If both are compatible, then only it is going to register. If the signature is varied, then you cannot register, right? Then what are the different types of delegates? The delegates are basically classified into two types. One is single cast delegate, another is multicast delegate, right? If a delegate is used for invoking a single method, so in this case, if I okay, let me comment this one and let me comment this one. So in this case, when I will run the application, then this delegate one, what is pointed, it is pointing at a single function. So it is nothing but a single cast delegate. So in this case, right, okay, let me change the things, do some work method executed, and this is do some work method. So in this case, if I invoke the method, okay, let me comment these things which are not required, and let me invoke this delegate instance. So okay, delegate to one, and let me pass some data, then some enum type. Okay, what is the enum type? Okay, not enum type, so it is some message. Okay, right. So this message, so in this case, as this delegate pointing pointing or referring to a single method, so it is going to be a single cast delegate. So in this case, you will see that only do some work method is going to be executed. Right, let me run the application and see the output. See, only do some method one is executed. Right, now what I'm trying to do is I'm going to attach another method to the same delegate instance. Now this delegate instance not only pointing to do some work method, but also it is pointing to do some work to method. That means if one delegate is referring to multiple method, then it is said to be a multicast delegate. And in this case, when we invoke the delegate instance, then all the method what are referring by this delegate is going to be executed. So in this case, you will see that when I will run the application, both the method are going to be executed. This is nothing but multicast delegate. Again, multicast delegate we are going to discuss in detail in our next video, right? Then where do we use delegates? So event handler, right? We are going to discuss how to use delegates with event handler. Callback method, we have discussed one method. Passing method as method parameter, right? Using delegate only you can pass method as a parameter. Len queue, multi-threading. In len queue and in multi-threading, we are going to use delegate. So once we discuss len queue multi-threading, then you'll get a better idea. Now, if someone asks you in how many ways we can call a method in C#, means there are two ways. How? Now, if the method is a static method, then we can call that method by using the class name, or directly when we can also call that method. And if the method is a non-static method, then we are going to call that method using the object, right? And another approach of calling a method in .NET is by using delegate. So in two ways we can call a method in .NET framework. That's it for today. In the next video, we are going to discuss multicast delegate in C# with some real kind example. In case you need the text document what I'm showing here, right? I will provide the link in the video description section. Just go to that link and get the document. Thank you. Thank you for watching this.